Hi folks,
Here's Lance.
and I'm Sarfaraz, and today we're going to explain to you how flight works.
Plane applies Newton's second law. The net force on an object is equal to its acceleration multiplied by its mass. F net equals ma, which you learned in class. The greater the force on the plane, the greater the plane's acceleration. And the propellers account for the net force on the plane. And the plane also applies Newton's third law. When one object exerts a force on a second object, the second object applies a force equal in magnitude but opposite in direction. And the propeller applies a force on the air, and the air pushes the propeller in the opposite direction, making the whole plane move forward. And the reaction force also exists on wings, which produce F lift, which we'll introduce later.
So, how a propeller works? The propeller is basically shaped in a way so that it pushes air backwards when it's spun by an engine in an actual plane. But in our demonstration, which we will show you, it is a rubber band. So our plane will be rubber band powered. The propeller it applies Newton's third law by pushing the air backwards, and therefore the air pushes on the propeller forwards. And since the propeller is connected to the plane, it pushes the whole system forward, as well as the propeller. So this is we are also going to explain to you how lift works. Um, and air resistance is really important when you deal with aircrafts. So the shape of the wing on the plane is very important to how it flies. Um, the shape of the wing causes pressure on top of the wing, air pressure on top of the wing, to be lower than that on the bottom because the air has to travel a further distance when it goes around the wing. So it needs to speed up to meet up with the air that's going from the bottom, and to speed up, it has to lower its pressure, making the pressure under the wing higher, and that causes the plane to go upwards. And obviously, the force of lift is perpendicular to the direction of flow, and that's how planes fly.
And here's our three-body diagram of a plane. You can see that F lift and F gravity is acting on the plane, and also F drag and F thrust. And we found a chart of coefficient of lift and a list of coefficient of drag, which we can use for calculating the value of F lift and F drag. And since the angle of attack of our plane is 50 degree, so we'll take the coefficient of lift 1.7. And for the coefficient of drag, the one on the bottom is the most similar to the shape of wing of our plane. So the coefficient of drag for our plane is 0.09. And for calculating F lift and F drag, first of all we found the formula for calculating lift, which is FL equals to the coefficient of lift times density of the air P times speed of the plane V squared and times the wing area, and divide everything by 2, and we got the wing area equals 0.048, and we put and also the density of air is known as 1.2 kilograms per m to the third, and we put everything in the formula. We got F lift is equal to 0.67 Newton, and for calculating the F gravity, since the mass of our plane is 0.0332 kilograms, and therefore Fg is equal to 0.33 newtons, and obviously F lift is greater than Fg, so that the plane could escape the ground and fly. And also for calculating F drag, we found the formula that Fd, the drag force, is equal to coefficient of drag times density of the air and times V squared times cross-sectional area, and divide everything by 2. And since the angle of attack is 15 degree, so the sectional area should be 0.049 times sine 15 degree, equals 0.012 meters to the second, and therefore f jack is equal to we sub in everything, and therefore f jack is 0.0089 newtons.
So planes also apply law of conservation of energy, which we learned about in this course. And basically, law of conservation of energy states that the total energy of an isolated system does not change. So the potential energy in the rubber band for our particular plane, the potential energy that it possesses before we release it is going to be the same that is released after the rubber band is let go, which would be equal, which would be converted into kinetic energy, thermal, as well as noise energy. So when we calculated this, we found it kind of tricky to find how we would calculate the potential energy in a twisted rubber band. So we used Google to try and help us find it, and we came across this forum over here, and basically someone asked the exact same question which we were looking for, and a reply, it gave a pretty creative way of finding it, and it worked for us. So first off, we had to find the K value of our rubber band, which we found to be over here, 39 newtons per meter. 49, sorry. And then we had to calculate the circumference of one loop, which is made when we twist the rubber band, which we had twisted 200 times. So we measured the loop of one of the circumference of one of our loops, and then we multiplied that circumference by 200 twists, and we subtracted the the resulting number from the original length of our elastic with elastic to the number which we got, and we plugged that number into um, the formula to find elastic potential energy, half kx squared. So now we will go through the calculations of what we got.
And we measured our diameter is equal to 0.004 meters, and we put this into formula C equals to 2 pi and times 0.004 and divide by 2 square, and we got 2.51 times 10 to the negative 5 meters, and multiply this by number of turns, which is 200, and we got L prime, which is the length of the wound rubber band, is equal to 5.03 times 10 to the negative 3 meters, and subtracted by the L initial, which is 0.29 meters, and we got the X value for our formula is equal to 0.28497 meters. Therefore, our elastic initial is equal to 1.99 joules.
So we compared that to a number which we got during one of our uh, one of our tests which we did, and we used e total. We used the law of conservation of energy to calculate it. Um, so first we added up all the we added up all the energies which were released. So um, E kinetic, Eg, and the force of drag, as well as EE, which was left over because we only calculated to the max height first, so only half of the elastic potential was used. So we calculated those and we put them in, and we found them to be 0.995 plus 0.0332 times 9.8 for our MGH for um, gravitational potential. Um, and then we multiplied that by 2.2, which was how high the height which we got, and we did half mv squared as well to find the kinetic energy, as well as the force of fd times delta d, which was our drag. We added all those numbers up and we came to 2.07 joules, and which was pretty close to the number which we got up here when we calculated elastic potential, and the percent error which we found was to be 8.1%. So now we're going to show you a demonstration of our plane flying. It's a very short video, and this is how it went. So demonstration of the flight. So that was our plane flying, and now we'll get back to the slideshow.
And we also make our own rubber band airplane, but it found it doesn't work because the propeller of our rubber band airplane is undersized, and the the total mass of the plane is too heavy, and the wing, which is made by fabrics and foam, produce not enough airlift. Um, yeah.
So that's why we had to go and use a store-bought airplane, which we just showed in the video. So now we're just going to talk about how flight affects different aspects of life. So first off, how it affects society. It's a huge part of how people get around, obviously, as well as how you ship goods and things of that nature. It makes for about 56.6 million jobs worldwide. It's involved in connecting people, and it provides about 2.2 trillion dollars of global GDP, which is massive.
And plane is really important technology nowadays. Um, for example, there are jet planes and fighters and bombers for military, and it also used for artificial rainfall.
How planes affect the environment, it's not a very good way that they affect it. It's very detrimental to the environment. In fact, um, the planes use large amounts of fuel to fly, and obviously the waste that is produced from these planes is not good for the environment. It was calculated that the greenhouse gas emissions that were released just by aviation increased by 87% between the years of 1990 and 2006 in the European Union. So we can look for that to maybe go down in the future with advancing technologies. These are our sources that we use, and
Thank you for watching.
thank you for watching.